Okay, now another useful fact here is that if you have two integers, if you have two prime numbers, then for these two prime numbers there exist two integers, x and y, such that if you multiply x with the first number, prime number, and y with the second, and add them up, the result is 1. Now we're going to do this by example for the long division, and in fact actually it applies to numbers that are m and n don't have to be prime numbers, they just have to be prime to one another. So that's important here, because the numbers that I'm going to use is 72 and 175, and they are not prime numbers, of course, but they're prime to one another. So let me do this by an example, and really what we're doing with this is called Euclidean math, or it's actually just long division, right? So you start with 175 and you divide it by 72. What is that? Well, that's 2 times 75, and then the remainder is 31. Now you take 72 and divide it by the remainder. Right? And so 72 divided by the remainder is 2 times 31 plus 10 as a remainder. Now we take the 31 and we divide it by the remainder, which is 10. And so we have 3 times 10 plus the remainder, which is 1. So this is where we stop. Now you wonder why? Well, let me show you why that is by just going the reverse direction. So we know that 31, the remainder was 1, right? So 31 minus 3 times 10 is the remainder was 1. So that's what we started with. Now let's take this 10 at the end and go back to the computation, which is the second line computation above. So we know that when we divide 72 by 31, the remainder is 10. So all that we do is we express the remainder. So 72 minus 2 times 31. So we take the expressions on the equation, the second equations, on the first expression on the right hand side and move it to the left hand side. Okay, now if you add this up, if you look at this, then and if you rearrange the term, then you have, instead of 31 minus stuff, you have 7 times 31 minus 3 times 72 is also 1. Now let's look at the 31. We know that 31 was the remainder of the first division in the first line. So we again put everything that is the first expression on the right hand side to the left hand side, so that we have the two expressions on the left hand side will be 31, and we put them in here in the parentheses. So so we know that that 31, the remainder, was 175 minus 2 times 72. Okay, and so then we can basically rearrange this expression, and at the end of the day what we have is that our number 1 that we're interested in is the same thing as 7 times 175 minus 17 times 72. Now why am I bringing this up? Well, I'm bringing this up because the numbers x and y are 7 and minus 17. Okay, so now this is an example here, but there's a general result that whenever two numbers are prime to one another, so that the greatest common divisor is 1, then we can find these respective numbers x and y so that we can find this expression. Now this is going to be crucial because but what we want to do is, we want to use the properties of these numbers in order to describe a deciphering function, so an encoding and decoding function. So this brings me to the next part. So